binomial distribution. So this is a pretty long exercise, so we don't have to do all of the homework, but maybe we just do a few questions, and then next time we'll do work on both G2 and G3, because G3 is quite short. People traditionally finish that pretty quickly. So, what we're going to do for you is we're going to look at a couple of different ways of doing the same thing we just did, and then an extension of it as well. So I really encourage you to have a read of these notes. They're listing the calculator instructions, and there's a couple of calculator processes we can use as well. But BPD, that stands for binomial probability distribution, and we were doing those calculations just before with this binomial distribution formula, CNK and so forth. We're going to come up with another way to do them on our calculator, X and P. Alright, so that's a single outcome or a single event. BCD is binomial cumulative distribution. And what it is it is a sum of cumulative events occurring. So let's get into it and explain the difference between them. The probability that a seed will germinate, that is grow into a plant or a seedling, is 0.85. We're going to put 6 seeds in one pot. Find the probability of germination of part A, exactly 5 seeds. Alright? So if we're putting 6 seeds into a pot, you think, how many could germinate? You could be really unlucky and have 0 germinate. You could have just 1 germinate. There's all of these possible things that can manifest. The case we're looking at is this one. This is the probability of the random variable taking the value 5. Alright? Now, if you were to do this based off what you learnt at the start of the lesson, you would go C6, 5, 0.85 to the power of 5, 0.15 to the power of 1, and that would generate the correct solution. Here's another way we can do it. Alright? In Run Math, I've listed the instructions there. Option state distribution binomial. We're going to put in BPD, open a bracket. The number of successes, is 5 out of 6 with a probability of success of 0.85. Alright, if we put that in, we will generate the same solution. Both of these obtain the same answer. So you can do whichever is faster. I'll come and see calculator help in a moment. Now, if you, another way you can do it, you don't have to do it in Run Math, you can do it in the statistics menu as well. And if you do it in the statistics menu, you don't have to remember the order these go. Alright, so there's utility in both. My preference is probably this one because it's much faster to write. And when you're performing these calculations, I really encourage you to write down the syntax of your calculator so that if you don't write the right probability, you can still get marks for having the right idea around what you are trying to put in there. Okay, so has anyone evaluated that?
Yeah, 0.399.
0.399, thank you. Alright, let's go on to B then, which says, how about the probability of between 2 and 4 seeds inclusive? So we're saying, we're performing this same experiment, but we want to know what's the probability of 2 germinating, 3, or 4. We have a cumulative event. Now, one way we could calculate this is to go, what's the probability of x equals 2 plus the probability of x equals 3 plus the probability of x equals 4. Like, it'd just take a long time to do. We calculate all 3 of those separately and add it together. Fortunately, there's a quick way to do it, and that is a BCD calculation. Alright? So what we're calculating, what this simplifies to, the way we can express it, is the probability that 2 is less than or equal to a random variable, which is less than or equal to 4. Between 2 and 4 seeds germinating, 2, 3, or 4. And so this is a BCD calculation. Alright? BCD for binomial cumulative. It is the lower boundary, upper boundary, number of trials, probability of success. So we have lower boundary 2, upper boundary 4. That's the domain, the restricted domain over which we're performing this experiment. 6 trials, and the probability of success is 0.85. Now we put that in our calculator, and it is going to tell us the cumulative probability of this event. Does anyone have the old calculator? Cool. Because You can still do it, it just takes longer. Alright, finish that.
22.3%, 0.223.
Thank you. When it says probability, we should always answer as a decimal. Alright, so that's part B. Part C, less than 3. Okay, if it says less than 3, it means 2 or less than 3. Okay, it's only if it says less than 3 inclusive that we need to include it. So this is again a BCD calculation. It's the probability of 0 plus the probability of 1 plus the probability of 2. So to answer part C, I'm just going to go probability of the random variable being less than or equal to 3. It's a BCD calculation. The lowest we could possibly have is 0 seeds germinate. The most we can have in this circumstance is 2. Sorry, that should be a 2. That's bad. 2. Number of trials, 6. Probability of success, 0.85. Alright. I've got this one. That's my calculator going.
5.89 times 10 to the negative 3.
Okay, well, that's good because I can explain how we write that. So it might be times 10 minus 03, or it might say something like 5.89 E minus 03, maybe the calculator pops up like that. Okay, so what that means, okay, when we have these negative powers, alright, it means this many zeros. That's what's going first. So here we've got minus 03, so we're going to have 0, 0, 0, and then we put these digits, 5, 8, 9, and we put a decimal place after the first. Okay, so it's as easy as that. We go 3 zeros, 0, 0, 0, we put these digits in, and then a decimal place after the first 0. Alright? Excellent. Okay, so that's the probability of having less than 2, less than 3. Okay, D says more than 3. Okay, so we're talking about more than 3. We're talking about this event, 4, 5, 6. Let's talk about the ways we can write that. Okay, so I've written it in 2 ways. Okay, this is what the question says: probability of more than 3. Now we are taking on discrete values. That means they have to be whole number values. The next whole number value that's more than 3 is 4, and we're including that one. That's why in this circumstance, these 2 statements are equivalent to one another. And the way we calculate them with the BCD notation, that's what we're putting in here. 4, lower boundary 4, upper boundary 6. 6 trials, 0.85 probability of success.
0.953.
So we have a very high chance of more than 3. Okay? Part E says exactly 3. Alright? So this is the probability of x equals 3. It's not a cumulative distribution, it's asking about one single event. This is a BPE. Okay, BPE for individual, BCE for cumulative. When it's an individual, it's just XNP. That is number of successes, number of trials, probability of success. It's quite low as well, 0.047 or something.
Yeah, 0.0415.
Excellent. Part F. What is the significance of the sum of your answers to C, D, E? Does anyone want to have a guess without adding them up? 1. Okay, they add to 1 because it's saying what's the probability of this event less than 3 plus the probability of this event plus the probability of that event. All probable events add to 1. So this is a fun exercise. Enjoy it. I encourage you to be comfortable with both processes on your calculator, in stat mode and in run math. But I also strongly encourage you to write out the calculator syntax so you can provide some justification for the solution you're generating. Another reason it's a good idea is because when you're doing the test, let's say you finish the test 10 minutes early because you're a jet, and you want to go back, have a look at your answers, you can see what you put in your calculator. Okay, so that's good. You don't need to write it all out again. So really strongly encourage it. Excellent. So let's get into some of 7G.2.